To be eligible for the Wisconsin Master Electrician exam, you must hold a valid Wisconsin registered journeyman electrician license. You need at least 4 years of experience as a registered journeyman electrician. You must also pass the National Electrical Code exam within the past 5 years. The application process involves several steps. Firstly, submit an application to the Wisconsin Department of Safety and Professional Services, or DSPS. Secondly, pay the application fee of $85. Thirdly, provide proof of your eligibility. The exam itself is computer-based and consists of 75 multiple-choice questions. You will have 5 hours to complete the exam. The topics covered include electrical safety, wiring methods, motors and generators, transformers, low-voltage distribution, lighting, overcurrent protection, and grounding and bonding. Preparation is key to passing the exam. Review the National Electrical Code thoroughly, as the exam is heavily based on it. Take practice exams to familiarize yourself with the exam format and pinpoint areas for improvement. Consider enrolling in study courses offered by trade schools or electrical associations to cover the necessary material. Join study groups to connect with other aspiring master electricians and support each other. Focus on safety and understand and apply safety guidelines to prevent potential accidents. During the exam, manage your time wisely to answer all questions. Eliminate as many incorrect answers as possible before selecting a response. After the exam, review your results to identify any areas that need further study. The exam is administered throughout the year at various locations in Wisconsin. To maintain your Master Electrician license, you must complete 30 hours of continuing education every 3 years. To further prepare for the Wisconsin Master Electrician exam, a detailed review of the National Electrical Code, or NEC, is essential. This includes understanding the NEC structure, which is organized into chapters, articles, and sections. Familiarize yourself with the definitions provided in Article 100, as these are fundamental to interpreting the code. Pay close attention to Chapter 2, which covers wiring and protection. This chapter includes articles on the use and identification of grounded and grounding conductors, branch circuits, and overcurrent protection. Understanding these articles is critical for answering exam questions related to circuit design and safety. Article 210 covers branch circuits, including the requirements for general-purpose appliance and individual branch circuits. Be sure to understand the requirements for the number and type of outlets required in different areas of a building, as well as the allowable loads on each circuit. Article 215 covers feeders, which are the circuits that carry power from the service equipment to the branch circuit overcurrent devices. Understand the requirements for feeder sizing and overcurrent protection to ensure adequate and safe power distribution. Article 220 deals with branch circuit, feeder, and service calculations. Mastering these calculations is essential for determining the proper size of conductors and overcurrent protection for various loads. Chapter 3 covers wiring methods and materials, including the types of cables and raceways allowed in different locations. Understand the requirements for installing these wiring methods to ensure compliance with the code. Articles 300 through 398 cover various wiring methods such as non-metallic sheath cable, metal-clad cable, rigid metal conduit, and electrical metallic tubing. Familiarize yourself with the specific requirements for each wiring method, including the allowed uses, installation methods, and support requirements. Chapter 4 addresses equipment for general use, including receptacles, switches, and lighting fixtures. Understand the requirements for installing this equipment to ensure safety and compliance with the code. Article 400 covers flexible cords and cables, including the types of cords allowed for different applications and the requirements for their use. Article 404 covers switches, including the requirements for their installation and use. Article 406 covers receptacles, including the requirements for ground fault circuit interrupter, or GFCI, protection in certain locations. Chapter 5 covers special occupancies, which are locations with unique electrical requirements due to the nature of the activities conducted there. Understand the specific requirements for these occupancies to ensure safety and compliance with the code. Articles 500 through 517 cover hazardous locations, such as those where flammable liquids, gases, or vapors are present. Familiarize yourself with the different classes and divisions of hazardous locations and the types of equipment permitted in each. Article 517 covers healthcare facilities, which have unique electrical requirements to ensure patient safety. Chapter 6 covers special equipment, which includes equipment with specific electrical requirements due to its unique function. Understand the specific requirements for this equipment to ensure safety and compliance with the code. Articles 600 through 695 cover various types of special equipment, such as electric signs and outline lighting, elevators, escalators, and moving walks, electric vehicles, and emergency systems. Chapter 7 covers special conditions, which are situations that require special electrical considerations. Understand the specific requirements for these conditions to ensure safety and compliance with the code. Articles 700 through 770 cover various types of special conditions, such as emergency systems, standby power systems, fire alarm systems, and optical fiber cables. Chapter 8 covers communications systems, including telephone, data, and cable television systems. Understand the requirements for installing these systems to ensure proper operation and safety. Chapter 9 contains tables and examples that are essential for performing electrical calculations. Familiarize yourself with these tables and examples to ensure accurate and compliant electrical designs. Understanding the NEC tables is crucial for determining ampacities of conductors, conduit fill, and box fill. Pay close attention to Table 310.15, which provides the ampacity of insulated conductors rated up to 2000 volts, and Table 310.16, which provides the allowable ampacities of conductors in raceway or cable or earth based on ambient temperature and number of current carrying conductors. Additionally, it's important to understand how to apply the correction factors for ambient temperature and the adjustment factors for the number of current carrying conductors in a raceway or cable. Mastering these tables and their applications will significantly enhance your ability to answer exam questions accurately. Grounding and bonding are crucial aspects of electrical safety and are heavily emphasized in the NEC. Understand the purpose of grounding and bonding, which is to create a low impedance path for fault current to return to the source, thereby tripping the overcurrent protective device and preventing electrical shock hazards. Article 250 covers grounding and bonding requirements, including the requirements for grounding electrodes, grounding electrode conductors, and equipment grounding conductors. Familiarize yourself with the different types of grounding electrodes, such as ground rods, ground plates, and concrete encased electrodes, and the requirements for their installation. Understand the requirements for sizing grounding electrode conductors and equipment grounding conductors based on the size of the service entrance conductors or the overcurrent protective device. Also, know the requirements for bonding metal enclosures, raceways, and equipment to ensure a continuous low impedance path for fault current. Overcurrent protection is another critical aspect of electrical safety and is covered in Article 240. Understand the purpose of overcurrent protection, which is to protect conductors and equipment from overloads and short circuits. Be familiar with the different types of overcurrent protective devices, such as fuses and circuit breakers, and their characteristics. Understand the requirements for selecting and installing overcurrent protective devices based on the ampacity of the conductors they protect and the interrupting rating required for the application. Also, know the requirements for protecting motor circuits and other special types of equipment. In addition to studying the NEC, it's essential to take practice exams to familiarize yourself with the exam format and identify areas where you need improvement. Utilize online resources, study guides, and practice exams offered by trade schools and electrical associations. Take the practice exams under timed conditions to simulate the actual exam environment and improve your time management skills. Review your answers carefully to identify the areas where you need to focus your study efforts. Consider enrolling in study courses offered by trade schools or electrical associations to cover the necessary material. These courses typically provide a comprehensive review of the NEC and other relevant topics, as well as practice exams and study tips. The instructors are often experienced electricians who can provide valuable insights and guidance. Join study groups to connect with other aspiring master electricians and support each other. Study groups provide an opportunity to discuss challenging topics, share study tips, and quiz each other on the material. Working with others can help you to better understand the material and stay motivated. Focus on safety and understand and apply safety guidelines to prevent potential accidents. Safety is paramount in the electrical industry, and the exam will likely include questions related to safety practices and procedures. Understand the hazards associated with electricity, such as electric shock, arc flash, and electrocution, and how to prevent them. Be familiar with the safety requirements outlined in the NEC, as well as other relevant safety standards, such as those developed by the Occupational Safety and Health Administration, or OSHA. During the exam, manage your time wisely to answer all questions. The exam is timed, so it's important to pace yourself and allocate enough time to each question. Read each question carefully and make sure you understand what is being asked before attempting to answer it. If you're unsure of the answer to a question, skip it and come back to it later. Eliminate as many incorrect answers as possible before selecting a response. Even if you're not sure of the correct answer, you may be able to eliminate some of the incorrect answers based on your knowledge of the NEC. This will increase your chances of selecting the correct answer. After the exam, review your results to identify any areas that need further study. This will help you to identify any weaknesses in your knowledge and focus your study efforts accordingly. Also, consider seeking feedback from experienced electricians or instructors to get their insights on your performance. Remember to stay calm and confident during the exam. Preparation is key to success, so make sure you're well prepared and confident in your knowledge of the NEC and electrical principles. Take deep breaths and try to relax. A positive attitude will help you to perform your best. To further enhance your understanding of electrical concepts and codes, consider delving into specific areas such as motor control circuits. Motor control circuits are fundamental in many industrial and commercial applications, and a thorough understanding of their operation and protection is crucial. Study the different types of motor starters, such as across-the-line starters, reduced voltage starters, and variable frequency drives. Understand the purpose of each type of starter and the applications for which they are best suited. Learn about the components used in motor control circuits, such as contactors, relays, timers, and overload relays. Understand the function of each component and how they work together to control the motor. Be familiar with the NEC requirements for motor circuit protection, including the requirements for overcurrent protection, short circuit protection, and ground fault protection. Understand how to size the overcurrent protective devices and conductors for motor circuits based on the motor's horsepower rating and full load current. Also, study the requirements for disconnecting means and control circuit wiring. Another important area to focus on is transformer connections and calculations. Transformers are used to step up or step down voltage levels in electrical systems, and a thorough understanding of their operation and connections is essential. Learn about the different types of transformer connections, such as delta-delta, delta-Y, Y-delta, and Y-Y. Understand the advantages and disadvantages of each type of connection and the applications for which they are best suited. Be familiar with the calculations involved in determining transformer voltage ratios, current ratios, and kVA ratings. Understand how to calculate the primary and secondary currents of a transformer based on its kVA rating and voltage levels. Also, study the NEC requirements for transformer protection, including the requirements for overcurrent protection and grounding. Additionally, it is vital to have a firm grasp of the requirements for emergency systems and standby power systems. Emergency systems are designed to provide power to essential loads such as lighting, fire alarms, and life safety equipment during a power outage. Standby power systems are designed to provide power to non-essential loads such as HVAC systems and manufacturing equipment during a power outage. Understand the NEC requirements for emergency systems and standby power systems, including the requirements for transfer switches, generators, and battery backup systems. Be familiar with the different types of transfer switches, such as automatic transfer switches and manual transfer switches, and the applications for which they are best suited. Understand the requirements for sizing generators and battery backup systems based on the load they are intended to serve. Also, study the requirements for testing and maintenance of emergency systems and standby power systems. Review low-voltage distribution systems, which are commonly used in commercial and industrial buildings to distribute power to various loads. Understand the different types of low-voltage distribution systems, such as radial systems, loop systems, and network systems. Be familiar with the components used in low-voltage distribution systems, such as switchboards, panel boards, and circuit breakers. Understand the function of each component and how they work together to distribute power safely and reliably. Also, study the NEC requirements for low-voltage distribution systems, including the requirements for overcurrent protection, grounding, and bonding. Furthermore, dedicate time to understanding lighting design and calculations. Proper lighting is essential for creating a safe and productive work environment. Learn about the different types of lighting fixtures, such as incandescent, fluorescent, and LED fixtures. Understand the advantages and disadvantages of each type of fixture and the applications for which they are best suited. Be familiar with the calculations involved in determining the number of lighting fixtures required to achieve a desired level of illumination in a given space. Understand how to calculate the foot candle level based on the lumen output of the fixtures, the area of the space, and the reflectance of the surfaces. Also, study the NEC requirements for lighting control and energy efficiency. Lastly, remember that continuous learning is crucial in the electrical field. The NEC is updated every 3 years, so it's important to stay current with the latest changes and revisions. Attend continuing education courses, read industry publications, and participate in professional organizations to stay informed about the latest developments in the electrical industry. By dedicating yourself to continuous learning, you'll be well prepared to pass the Wisconsin Master Electrician exam and succeed in your career as a Master Electrician.